February 3rd, 2002. We're in New Orleans at the Louisiana Superdome for Super Bowl 36. The game is tied with 81 seconds left on the clock, and the New England Patriots are about here, moving this way, and they need to end up somewhere here to have a chance to win the game, either off of a field goal or touchdown. In normal football, up to 40 seconds can run off the clock between plays. This will not do to win. Instead, they must employ a strategy known as the 2-minute drill, whose goal is simple: move down the field in as little game clock as possible, and to score on the last play of the game. There are many ways to stop the clock: incomplete passes, running out of bounds, spiking the ball, or a plain old timeout, of which New England has none. You can skip a huddle to save time between plays. Some teams do not understand this. For a recent example, following a Thanksgiving game in 2024, Chicago Bears coach Matt Eberflus was fired after coaching the worst 2-minute drill in my life. I am not showing you this. It is simply too ugly. Fortunately, leading the offense is a young Tom Brady, now widely considered the GOAT of American football, and in the next 80 seconds, he leads the fifth of his record-setting 72 game-winning drives. Tom Brady had a flair for the dramatic, as all 6 of his Super Bowl wins with the New England Patriots ended with a game-winning drive in the fourth quarter or overtime. A good 2-minute drill is some of my favorite sports to watch, and as such I've always wondered what football would look like if a team played like every second on the field was precious. Tom Brady and the Patriots came close to showing what that looked like in Super Bowl 51, coming back down 28-3 to win in overtime, and played like this for the last 25 or so minutes of game clock. But it was not sports that showed such marvelous efficiency and urgency, but a math book I was using in my courses at the same time as Super Bowl 51. There is a problem with a lot of math books, and textbooks more broadly. They can be long, rambling, and often do not know what they want to do with themselves. They cater to mass audiences so that teachers might pick and choose how they might teach a course. And these teachers' goal is often to check all the boxes that an administration requires. And if not even the book cares about where it ends up, why should the students care? Imagine if football wasn't about trying to score more points than the other team. Then the Super Bowl would not be the most watched program on American television each year, and would at best be relegated to local channels of the host city and to the home cities of the 2 competing teams. But how can we write better math books? I can't give a full answer, but I want to show an example. I would like to introduce you to the GOAT mathematical textbook, Principles of Mathematical Analysis, also known by its author, Rudin, or affectionately called Baby Rudin, since he wrote several larger books on analysis in addition to this one. For those of you who are familiar with this book, I can hear some of your objections now. The book is too terse, it moves too fast, it is unmotivated, it is too abstract. And my response is simple. You are too wordy, you are too slow, you are illiterate. You are too dependent on examples. This book is Tom Brady, and you have no limbs to stand on. This book is a masterclass in efficiency. It really is like watching good football. Every definition, every theorem moves the ball towards the objectives of learning real analysis. Starting with the rational numbers, it builds the real numbers, the complex numbers, and the real vector space in a mere 17 pages. In research comparing similar sources, they may cover as much ground in nearly 4 pages, on larger sheets of paper. And it is ultimately better for students that not only teaches the math, but it shows how math can be done. This efficiency can also answer another objection, that lack of motivation. If this is your objection, you do not understand, since your motivation is probably an easy A to gain some other utility. Rudin's motivation is to get to the great ideas of analysis as fast as possible, no matter the cost. He takes 18 pages of Chapter 2 to explain the topology of metric spaces, which seem like overkill and an unrelated diversion, but it allows for the next chapter on sequences and series to cover all sorts of important and interesting results in a fraction of the time. And this happens throughout the book. You can tell the motivations just by reading the table of contents. Chapter 7, bunch of ideas, boom, Stone-Weierstrass. Chapter 8, bunch of ideas, boom, Fourier series. Chapter 9, bunch of ideas, boom, Stokes theorem. Chapter 10, bunch of ideas, boom, L2 functions. Heck, for comparison, I pulled out a copy of All the Mathematics You Missed by Thomas Garrity, a review book that has few, if any, proofs, and Rudin's chapter on functions of several variables proves that the material in fewer pages than this book takes to review the same material. Finally, we get to the complaint of abstraction. This is a more subjective argument, but the abstraction it does introduce is relatively grounded in understanding the real numbers. I'm sure somewhere out there is a category theorist who will say that all content of Rudin can be reduced to 15 pages of commutative diagrams or something like that. But again, our goal is to get to the great ideas of analysis quickly. And several hundred pages of category theory needed to understand such things adds a great amount to the length to what would be an algebraic argument. If there are any tendencies that students at the stage of a first analysis course suffer from, it is the inefficient desire to show every step in slow motion. It is the motivation to simply pass the course. It is the refusal to embrace necessary abstraction. Rudin does not only teach real analysis, it teaches a way to approach mathematics. In the end, Rudin is a short and efficient book in comparison to the long tomes of other analysis books and even other math texts. And I think more books like that are needed in math to make it more accessible to a universal audience. For comparison, many of the great philosophers have a short, efficient book in addition to one of their longer books. And these short books are the ones most likely to be cited when the ideas of that author are expressed, as we can see in this table that I stole from Kraft. Most math books are written like they want to be on the right side of the table, and Rudin, in my opinion, plants his flag much closer to that left side, and I must commend him for it. If you like this content, make sure to like and subscribe. Thank you for watching.